Hey guys, welcome to Pre-Calc, lesson 10.5, Trig expressions and identities. Before we get to that, let's do a quick warm-up here of our inverse functions. Let's start with arc sine negative 3 over 2. So first of all, let's really have parentheses around it. But remember here, when I'm asking you for arc sine or inverse sine, it's looking for an angle. And it's looking for the angle where sine has a value of square root 3 over 2. You should recognize square root 3 over 2 from your 30, 60, 90 right triangle. So it's just a matter of picking the correct one. And sine of 60 degrees is square root 3 over 2. However, answer is not 60 degrees because of that. So remember, when we're finding arc sine, I can be in quadrant 1 or quadrant 2, basically between negative 90 degrees and positive 90 degrees. Or if I'm talking radians, negative pi over 2 to positive pi over 2. So I wouldn't say my answer is 60 degrees. I would say it's negative 60 degrees. If I'm talking radians, negative pi over 3. All right, the next one, arc cosine negative 1. Well, again, arc cosine means I'm looking for an angle. When I see cosine and negative 1, I'm thinking unit circle. All right, so cosine is the x value. Where is the x value negative 1? It's right here. So that would be at 180 degrees or pi radians. All right, the last warm-up question. Given the harmonic function, d equals 7 cosine pi t over 10. Find the first time the spring reaches equilibrium. Find the height at time 10 seconds. All right, so pretty simple here. I've got a positive cosine. I know the amplitude is 7. My b value is pi over 10, frequency. So the period is 2 pi over pi over 10, and a simple copy change flip gives you 20. So I'm going to sketch a positive cosine, so I know it kind of looks like this, and the period is 20. So let's quickly set up some axes. Period is 20, divide that into 4 blocks. So if that's 20, that's 10, that's 5, that's 15. Amplitude is 7 there, negative 7 here. Remember what positive cosine looks like. I start at maximum, go to equilibrium, minimum, equilibrium, back to maximum. Concave down, concave up, concave down. All right, so there's one cycle of that harmonic motion. Find the first time the spring reaches equilibrium. Well, that'd be right here. So our unit doesn't say, I guess, seconds. So part A would be 5 seconds. Part B, find the height at time 10 seconds. So here's 10 seconds. What is your height? Negative 7. Now let's talk about some trig expressions and identities. First thing, we'll do a quick review of our reciprocal functions. Secant theta, as I'm sure you guys already know, is 1 over cosine theta. So you can replace this with the fraction 1 over cosine. Cosecant then, obviously, is 1 over sine theta. Tangent theta, it says quotients, can be expressed as sine theta over cosine theta. And cotangent, since it's the reciprocal of tangent, can be expressed as cosine theta over sine theta. Now, occasionally, it might be helpful to replace it with a 1 over tangent, but most of the time, and I'll explain this below, we like to write things in terms of sine and cosine. Our Pythagorean identities, this is an important one right here, because we can get every other trig identity from that single one. First, I'll just start up above. If sine squared plus cosine squared equals 1, then sine squared theta by itself is equal to 1 minus cosine squared theta. And cosine squared theta by itself is equal to 1 minus sine squared theta. So sometimes you might see this in an expression, and you can just replace it with a sine squared. Other times you might see 1 minus sine squared, and you can replace it with cosine squared. Now notice they have to be squared. If you don't see a squared, you can't replace it. Very important. Now there are 6 other trig identities we can get. The first one we can get from this if we were to divide every one of these terms by sine squared theta. So what would I get? This would give me a 1. This would give me cotangent, and that would give me cosecant. So I have this. 1 plus cotangent squared theta equals cosecant squared theta. Now, let me move this one out of the way to show you how I get the other one. The other one I can get by taking this expression here and dividing everything by cosine squared theta. So this gets me tangent squared, that's a 1, and that gets me secant squared. So my other one would look like this. Tangent squared theta plus 1 equals secant squared theta. Now notice you can change the order of both of these. They're very similar. The cotangent squared plus 1 goes with cosecant squared. The tangent squared plus 1 goes with the secant squared. And again, I can move this one over here. I could move this one over there. You could put both of these on the same side and move the one over there. So we don't deal a lot with this, so I don't like to write the other ones down like I did with these here. These are a lot more common, but we will use both of those. All right, so steps or strategies for simplifying trig expressions or for proving trig identities. Well, first thing we can do is use a trig identity substitution. So that's kind of like what I said up above. If you have a 1 minus cosine squared, you could replace it with a sine squared. Second, and this is probably the one we do most often, rewrite each term in terms of sine theta and or cosine theta. So if I'm given a tangent theta, I would replace it with sine theta over cosine theta. And lastly, probably the most challenging, use fundamental algebra skills. So that could include factoring. You know, sometimes maybe we have to factor. Sometimes we have to do the opposite. Maybe we have to use FOIL, multiply two binomials. That could include adding, subtracting, multiplying, dividing fractions. That's always fun. It could involve distributing, and etc. All right, so let's practice a couple. Start off easy. Number 1, sine theta times cotangent theta. I want to simplify that expression. It's an expression. I'm not looking for an answer. I'm just looking for a simpler expression. Well, here what I'm going to do is a quick substitution. Sine theta stays sine theta. You never change a sine theta or a cosine theta, but you can change everything else. Cotangent from up above, we said, well, that's the same thing as cosine theta over sine theta. And I'm multiplying those two terms, so now I think of it as, multiplying fractions. If I'm multiplying fractions, what I try to do is cancel something in the numerator with something in the denominator. Great. All that's left is cosine theta. There's your simplified expression. Question 2 is a little bit more involved. I see a cosine x outside of parentheses. So up here, distribute. I'm going to multiply these. Well, you can do that first, and then you can substitute. Or you can substitute first and then distribute. It doesn't really matter. My personal preference, to be honest with you, is just to do my substitution first. Get everything in terms of sine and cosine first, then do your operations. But you don't have to do it in this order. So I will replace secant with 1 over cosine x. And then I have minus cosine x. Okay, well now I need to distribute. So I'll multiply cosine x times 1 over cosine x. Well, I'm going to write it out here because it's notes, but I think you can see what's going to happen. This stuff will cancel and it just gives you a 1. But because we're distributing, I'll write it out first. Cosine x times 1 over cosine x minus cosine x times cosine x is cosine squared x. Well, now I think you can see that, those cancel out. Everything cancels, so it's a 1. Remember, it's multiplication. So this becomes 1 minus cosine squared x. And then from up above, the Pythagorean identity, 1 minus cosine squared x is equivalent to sine squared x. So there's my simplified expression. Example 3, we have cosine x divided by secant x. As I just mentioned, I like to do my substitution first, so I'll replace secant x with 1 over cosine x. Now, how do we deal with this? Dividing by a fraction. copy, change, flip. Copy this, change to multiplication, and then flip that bottom fraction. So 1 over cosine x just becomes cosine x over 1. Cosine x times cosine x is simply cosine squared x. Do not replace that with 1 minus sine squared x because that is more complicated. It's 2 terms versus just 1. All right, the next one, for whatever reason, students have a hard time seeing this occasionally. Think of this as x plus 1 times x minus 1. How would you do that? Well, that's just x squared minus 1, right? Multiply it out. So instead of x, we have secant theta. So instead of x squared minus 1, this is just secant squared theta minus 1. Secant squared minus 1. Here's a secant squared, here's a 1. What would we get if I subtract 1 from both sides? Oh, that would give me tangent squared theta equals secant squared theta minus 1. So there's my secant squared minus 1. What does that equal? Tangent squared. So that just equals tangent squared theta. All right, and the last one of this group, 1 minus sine squared over cotangent squared. So here, 1 minus sine squared, I will definitely replace that with cosine squared theta. And cotangent squared, I'm going to replace with cosine squared theta over sine squared theta. Now, we've got a complex fraction again. Copy, change, flip. Copy the top fraction, which is cosine squared over 1. Change to multiplication, and flip the bottom one. So that becomes sine squared theta over cosine squared theta. Now, when I go to multiply these, check this out. Now, this is cosine squared theta over 1. Those cancel, and you're just left with sine squared theta. Done. All right, proving identities. Basically, we do what we just did up above on two sides of an equation, but it's really not an equation. When we're proving identities, you have to think of this as a wall. You can't cross it. So I can't add 1 to both sides. I'm not solving an equation. Those equation properties don't apply here. So what I like to do here is kind of draw a squiggle down to remind me I cannot cross that. I basically need to simplify each expression so that this side over here is identical to this side over here, like they're both sine x. All right, and my general rule of thumb is to look at both sides and to pick the side that's easiest and simplify that first, because then I'll be pretty confident what I need to get the other side to be equal to. So in this case, multiplication is always easier than addition, because addition usually leads to fractions, which leads to common denominators, which I have to do, but it's a little bit more challenging. So I'll deal with this first. I think that's going to be easier. So cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. Well, that didn't work out the way I wanted it to. I was hoping I get something to cancel here, but if I were to multiply those two fractions, I simply get 1 over sine theta times cosine theta. Well, not nearly as easy as I thought. So now let's go to the other side. And there's a couple approaches here. Notice this is in terms of sine and cosine. Here I've got tangent and cotangent. So what I need to do is convert these to sine and cosine. Tangent is sine theta over cosine theta, plus cotangent, which is cosine theta over sine theta. Now I need to add these two fractions. I need to get a common denominator. The common denominator has to have a cosine and has to have a sine. So that's going to be sine theta times cosine theta. Get my denominator first. Which isn't bad because look over here. That denominator is sine theta times cosine theta, so I've got that in two fractions. So how do you get this to equal that denominator? Multiply the top and the bottom by sine theta. So sine theta times sine theta is sine squared theta. So that's sine squared theta there. How do you get the next one to have this denominator? Well, I've got to multiply by cosine theta over cosine theta. So that gives me cosine squared theta on the top. Now when I add those fractions, you add your numerators. So that's sine squared theta plus cosine squared theta over sine theta times cosine theta. And notice this. Sine squared plus cosine squared, that equals 1. You have to indicate that you're substituting that in. You don't need to write it all out again, but that's just a 1. So that gives me 1 over sine theta cosine theta, which is exactly what I have on that side, and I've just proven that identity. So that's about as tough as it's going to get. We start out with a very, very challenging one. Question number 2, not as challenging. All right, so again, here's my equals. I cannot cross over that wall. Secant theta, well, that's pretty easy. Secant theta is 1 over cosine theta. I can't do much more with that. Over here, I'm going to substitute sine and cosine in for each one. So tangent is sine theta over cosine theta. Cosecant is 1 over sine theta. I think you can see what happens here. That's pretty nice. I go to multiply those fractions. This sign in the numerator cancels with that sign in the denominator, and what we're left with is 1 over cosine theta. Nothing else to do there. Both sides are identical. I've proven that identity. All right, the last page of notes, we've got 2 relatively straightforward and 2 pretty high level. I'll do the 2 straightforward ones first, starting with number 3. So as I look at this, on the left side, I just have cosine squared theta. So kind of the nice thing about number 3 is I know I don't have to do anything to that left side. I can't really make that any simpler. So on the right side, I want to convert cosecant to 1 over sine theta times sine theta minus sine squared theta. And again, I'm multiplying these two. That really is a fraction. Those cancel. So that gives me 1 minus sine squared theta. And Pythagorean identity, 1 minus sine squared theta is equal to cosine squared theta. And that's exactly what I have on that side. So that one's done. Let's skip down to number 5. All right, looks challenging to begin with, but I think you'll see here why this cleans up nicely. It's a good opportunity for me to point out this right here does not equal sine theta. Remember, it doesn't work unless this is squared. No squared, no identity. So I really can't plug anything into this, and I can't substitute anything into that. So this is just going to stay. I need to get this side here to equal this expression. Well, let's start. Cosecant, all right, is 1 over sine theta minus cotangent, which is cosine theta over sine theta. Well, this is swell, right? We've got 2 fractions. Denominators are already the same. All you have to do is add them together, and I get 1 minus cosine theta over sine theta, which is exactly what we have on the other side. So that one worked out great. It was not nearly as challenging as I first thought. Now, let's get to one that is a little bit more challenging. Question number 4. That's just sine theta, so you don't have to do anything more with that side. The challenge is going to be to get your left side equal to sine theta. So first thing, I know it looks more complicated, but we're going to convert everything to sine and cosine. Secant is 1 over cosine theta. Cotangent, cosine theta over sine theta, plus tangent, which is sine theta over cosine theta. Now, we've already done one like this. I need to get common denominators. All right, so I'm going to rewrite this. I better start writing small here. 1 over cosine theta. Now, my denominator, it's got to be sine theta cosine theta. Sorry for the small writing. I just got to fit it in. Basically, what I need to do is I need to multiply this fraction by cosine theta over cosine theta. So that's going to give me cosine squared on the top. The other one I need to multiply by sine theta over sine theta, and that's going to give me sine squared theta. Now, I'm not going to write this down because I don't have room, unfortunately, but when I add these two together, maybe I'll just write over here on the side. This is going to equal cosine theta plus sine squared theta over sine theta times cosine theta, and that's just going to be a 1. So I'm going to replace all of this with 1 over sine theta cosine theta, okay? And then don't forget, this is still going to be in the numerator. So now I get 1 over cosine theta over 1 over sine theta cosine theta. Now, what I'm going to do next is copy, change, flip. I'm going to multiply this by sine theta cosine theta over 1. Copy, change, flip. And what's going to happen is the cosines are going to cancel. So all that's left then is 1 times sine theta which is just sine theta. Now, again, I apologize. I don't have room to write all of that, but I hope I just showed you that we get sine theta equal to sine theta. All right, next one. Also very challenging. I've got 1 over 1 minus sine x plus 1 over 1 plus sine x equals 2 secant squared x. Well, I can do a little bit here. I know secant is 1 over cosine, so be careful though. This is by itself. This stays in the numerator. So this expression is equal to 2 over cosine squared x. And maybe that just saves me a little bit of writing in the end. All right, well, here's the challenge. I need to add 2 fractions. The only way to add 2 fractions is to get common denominators. Well, the denominator here is going to be, I got to write small again, 1 minus sine x times 1 plus sine x. Right? I've got to include that, 1 minus sine x times 1 plus sine x. How do I get the denominator? Well, this I have to multiply by 1 plus sine x over 1 plus sine x. Well, since I'm just multiplying a 1 by that, I just get this in that denominator. 1 plus sine x. Well, how do you get your next one? This one I have to multiply by 1 minus sine x over 1 minus sine x. Since that's just a 1, I get 1 minus sine x. So right now it looks super complicated, but check this out. I know my denominator's got to be this, so maybe I just write that down first. Well, let's do something else first. Sorry, I was going to write it down, but I'm lazy. I don't want to write it all out again. Think about what we would get if we multiplied that together. If I multiply this, 1 minus sine x times 1 plus sine x, it's kind of like 1 minus x times 1 plus x. It's just 1 minus sine squared x. When you go to combine your numerators, right, you're adding, you get 1 plus 1. That's going to give you a 2. Then check this out. Positive sine x minus sine x, those cancel. So my numerator is just this 2. So what does this give me? 2 over 1 minus sine squared x. Well, that's just cosine squared x. So that gives me 2 over cosine squared x, which is exactly what I have on that side. So finally, we finished that identity. All right, and that concludes the notes for day 5. As usual, guys, if you have any questions, don't hesitate to reach out and ask. Thanks a lot for watching, and we'll see you in class soon.